For those of you who are still lost, here's example number 5 from the worksheet. What's the empirical formula of a molecule containing 18.7% lithium, 16.3% carbon, and 65% oxygen? Let's review. A formula tells us how many atoms of every element is in a compound. So here we have 2 carbons and 6 chlorines. We can think of this as a ratio. For every 2 carbons, we have 6 chlorines. The empirical formula is simply the most reduced ratios of atoms or elements in a compound. If I were to take this ratio here and reduce it to its lowest form, you would reduce it to 1 carbon and 3 chlorines. And this would be our empirical formula. We have 1 carbon and we have 3 chlorines. And that's our empirical formula. So to determine the empirical formula of this molecule, I'm really determining the subscripts on lithium, carbon, and oxygen. These subscripts are the ratio of atoms for these elements, or we can think about it as the ratio of moles of each of these elements, and that's how we are going to do our calculations, using moles. Our steps are percent to grams, grams to moles, divide by lowest, and then make whole. Because we're talking about mole ratios, I need to find the mass. Here they give us the percentages. With percentages, I can pick any amount of mass and I can calculate the percent of mass for lithium, carbon, and oxygen. But since it's in percentages, the easiest number to pick is 100. If I pick 100 grams, then 18.7% of lithium turns into 18.7 grams. And 16.3% of carbon turns into 16.3 grams, oxygen 65.0 grams. This is what it means by percent to grams. The next thing I have to do is grams to moles. Now I'm just going to convert grams to moles using the molecular weight of each element. And if you're lost here, you should refer to your mole island. I've now converted every element to moles of that element. 2.69 moles of lithium, 1.36 moles of carbon, and 4.06 moles of oxygen. Step 3 is to take the moles that I've calculated and divide by whichever one of these 3 numbers is the lowest. 1.36 is my lowest number of moles, so I'm going to divide all 3 of these by that number. Now I've divided by the lowest number because my subscripts that go here and here and here have to be in whole numbers that are greater than 1. So if I divide by the lowest number, I get a number 1 and then numbers that are greater. So I can compare them. Now I need to make all the numbers whole numbers. Right here I have 1.98, 2.98. Those aren't whole numbers, but they're close enough that I can round them to 2 and 3. So now I have whole number ratios for all my elements. I have 2 lithiums, 1 carbon, and 3 oxygens, and these will become my subscripts. By plugging in these numbers as my subscripts, I get my final answer: lithium 2, carbon 1, oxygen 3. We have determined the empirical formula. The molecular formula could be a multiple of this formula right here. So if I were to compare this empirical mass with my molecular mass, I would know if I would double or triple or say quadruple these subscripts or keep them the same. Please view the video above that compares molecular formula to empirical formula to do those calculations.